Let's try all the problems for a 6th grade NJSLA practice test together. If you'd like to download a copy of this blank PDF or the annotated answer key PDF, you can find a link to that below. If not, I still encourage you to get the most out of this video to grab some paper, something to write with, and let's go ahead and do some math together. Alright, so let's go through and see. This is going to be Unit 1. Let's see, we're not going to be able to use a calculator for this one, I don't think. So let's go right on to this first one. It's going to be number 1 right over here. Alright, a class of 25 students is going to be sharing 100 markers. One day we have 5 students absent. Which statement is going to be true? Alright, so if there are 5 students absent, so we have 25 minus 5. How many students are there really? There are going to be 20 students that are here. And let's see, these 20 students are going to be sharing these 100 markers. Looking at the answer choices, we see that for every certain amount of students, we have how many markers? Students to markers, students to markers. This is a classic ratio type of problem here. So we have 20 students here for how many markers? There's going to be 100 markers. Let's see, we can go ahead and divide both of these numbers by, let's see, we can divide them both by 20, right? If we go ahead and do that, that's going to be basically 1 student for every 5 markers. So if we're going to choose an answer choice that makes sense here, let's go with D. So when it says for each student, that's going to be 1 student. There are going to be 5 markers, so that's going to be 5 markers. Let's check out number 2. For number 2, we have the area of a rectangular patio is going to be this many square yards, and the length is going to be 1.5 yards. What's the patio's width in yards? Okay, so if we want to just look at this as a picture, we can see we have a rectangle. We know the area or the amount of space inside here is going to be this 5 and 5/8. I'm going to say area equals 5 and 5/8. And we know the length is going to be 1.5 yards. So I'm going to go ahead and just put that 1.5 over here. 1.5 yards. They're asking what is that width going to be. So that width I'm going to mark over here. I'll just make it this W over here. So keep in mind, to find the area of a rectangle, it's equal to length times width. If we're trying to find the width here though, now if we're trying to find the width specifically, we can rearrange this formula and say we can find the width if we go ahead and take the area and then divide that by the length, right? Our length here is going to be this L. So let's go ahead and find this W, or the width. The width is going to be this 5 and 5/8, 5 and 5/8 divided by this 1.5. So let's go ahead and write divided by 1.5. Now, when you divide fractions, keep in mind that we're going to turn them into improper fractions. So 5 and 5/8 is going to be the same thing as 45/8 if you turn it into an improper fraction. And then this 1.5 as an improper fraction is going to be 3/2. Then when we go ahead and divide fractions, we really just keep that first fraction. Our algorithm is keep the first fraction, and we can rewrite this division problem as multiplication and multiply by the reciprocal of that second fraction. Okay. At this point, you can go ahead and cross cancel, or you can just go ahead and multiply and then simplify here. I think what I'm going to do here is just multiply the tops and bottoms. If you know how to cross cancel, go ahead and do so, but not everybody maybe feels as comfortable doing that. So 45 times 2 is going to be 90, and then this 8 times 3 is going to be 24. All right, so you look at our answer choices, none of them say 90 over 24, so maybe we can go ahead and simplify this thing. So 90 over 24, what's a common factor you could divide these both by? You could divide these both by 2, so that would be 45 over 12. And if you go ahead and divide these both by maybe 3, that we would get 15 over 4. And I think that's as far as we can go. So this is going to be 15 over 4. But what's that as a mixed number? Well, 4 goes into 15 3 times with 3 left over. That's 3 times 4 is 12 with 3 left over, so it's 3 3/4. So we're going to be looking for a width here that is going to be 3 3/4. I think that's going to be answer choice A. All right, cool. Let's go ahead and check out number 3. For number 3, it says the coordinate plane shows the location of point W. That's right over here. Keep in mind that this is going to be in quadrant 2, so maybe that helps to see or just refresh your memory. Quadrant 1, quadrant 2, quadrant 3 would be down here, and quadrant 4. All right. It says down as our question says, what's the value of the x coordinate of the point W? Write your answer as a decimal to the nearest 0.5 or 5/10. So if you have a point, keep in mind we have x comma y. When they say the x coordinate here, I'm going to go ahead and just highlight here, it says x coordinate. They are really just asking what's this number right over here. Okay, so let's see, if we're trying to get to point W, we would start at the origin, we would move, it looks like maybe 3.5 units to the left here. I'm going to go ahead and mark that on this coordinate plane, so move this way. This is going to be negative 3.5 moving to the left. So if you're writing your ordered pair, it would be negative 3.5 because they're going to the left. And let's see, then you have to go up here. So if we go up, this is going to be up, how much? This is up 1.5, it looks like, so positive 1.5. But again, if you're writing a positive number, you don't have to write that plus. So this is gonna be positive 1.5 here. All right, so it says enter your answer in the box here. Again, they're just looking for the x coordinate, and that x coordinate here is just going to be this negative 3.5. So let's go ahead and just write x would equal negative 3.5. And I think if you're just entering the answer in the box, you would just put this negative 3.5 in there. Okay. All right. For number 4, it looks like we have just a little bit of long division, some standard algorithm, but with decimals here. Keep in mind when we're dividing, when we take a look at this number here, this is our divisor. We like it to be a whole number. So if you go ahead and multiply by 10, we can make it a whole number. And so if you do that to the divisor, you should also do this to the dividend as well. Multiply that by 10. So you could rewrite this division expression. So you can rewrite this division problem as 338 divided by 325. And so we're going to get the answer to this problem, which would be the same answer as the original. As long as we multiply or divide both numbers by the same value, we'll get the same answer. Now, before we even solve this, if you're asking yourself, how many times does this 325 fit into 338? It's only going to fit in one time and maybe a little bit more. So we should be getting an answer that's like 1 point something, right? So let's see if we can figure this out. When you're setting up your long division, 338 is going to go as our dividend inside this division house. And the 325, that's our divisor. We wanted that to be a whole number. 325 fits into 338 one time. So that's going to be 325 here. We subtract to see how far off we were. 8 minus 5 is going to be 3. 3 minus 2 is 1. So we have a remainder of 13 so far, right? So you wouldn't stop here. You would then keep going by adding a decimal and a 0, because 338 is the same thing as 338.0, right? Now, if you do that in the dividend in our quotient up here, you should also add this decimal. Now let's go ahead and bring the 0 down and continue this process here. Now, how many times will 325 fit into 130? It's not going to fit in a whole number of times. You're going to say it's going to fit in 0 times here. So it's going to fit in 0 times. Now just multiply as we normally do. 0 times 325, that is going to be 0. We're going to subtract, and we still have 130. Okay, we still have a remainder, so let's go ahead and add another 0 inside this dividend, because that doesn't change anything in the problem. And we now have 1300 here. And now the goal is to figure out how many times 325 fits into 1300. So we can do that on the side, 325. Again, you don't get a calculator for this, so you just kind of have to reason through it. 300, if I estimate 325 as 300 maybe, if I do times 4, I think that's going to get close to 1200, or a little more than 1200, right? So 4 times 5 is 20, carry the 2. 2 times 4 is 8, plus 2 is going to be 10, carry the 1. 3 times 4 is 12, plus the 1, that's going to be 13. So wait, that's exactly what we were maybe looking for here, so we can actually stop doing this long division. So it goes in exactly 4 times, which is good news for us because we can finally stop this long division. And so that remainder is 0, so the exact value. And we said earlier it was going to fit in maybe a little more than 1 time, so 1 4/100ths times to be exact. So typically if this is on the computer, you would enter this exact value on there, but on this paper version or PDF version, that would be our answer. All right, let's check out number 5. For number 5, it says which equation, so these are all equations because they all have equal signs here, right? Showing that 2 expressions are equivalent, maybe. It says with exponential expressions are true. Okay, so select all that apply, so there could be more than one right answer. Let's see, if we look at just answer choice A, if we look at this 3 to the 3rd power, that's 3 times 3 times 3. So I guess the question is that equal to 3 times 3? No, that is not equal to 3 times 3. So this one doesn't make sense. Let's go ahead and cross that one out. That one doesn't work. If you look at the second answer choice, this is 5 to the second power. That's 5 times 5. Does that equal 5 times 5? Definitely yes, that one does work, so I'm going to say yes to this one. For C, let's see, we have 5 to the fourth power. That's 5 times 5 times 5 times 5. That little 4 exponent means we have 4 of the base. The question is that equal to 4 times 4 times 4 times 4 times 4, and that's definitely not going to be true here. So if you, again, multiply all these 5s together, you're going to get, I think, 625 or something, and then none of these would get you a multiple of 5 because 4s are just not multiples of 5, so there's no way that's going to work there. All right, so this one's not going to work. For this next one, you can try, and sometimes it's maybe you're noticing that you could actually condense it and that would be faster. So 1, 2, 3, 4, 5, 6. There's 6 of these 7, so let's try practicing going the other way. This is 7 to the 6th power. Is that equal to 6 to the 7th power? Just like in answer choice C, this is not true. You can't just reverse those things and have that be a true statement. And you can try and multiply it out, and I promise it doesn't work. It doesn't make sense. Okay. For this next one, we have 1, 2, 3, 4, 5, 6 of these 7s. So if we rewrite this, this is going to be 7 to the 6th power. Is that equal to 7 to the 6th power? Yes, that's true. So E is going to work here. And then for this last one, we have 1, 2, 3, 4, 5, 6 of these. So you can rewrite this as 7 to the 6th power. Is that equal to 7 to the 7th power? Nope, that's not true. So we're going to say this one also does not work. It's close to being the same, but not quite. All right, so there's 2 correct answer choices for this one. It's going to be B and it's going to be E here. Okay. Let's take a look at number 6. For number 6, it looks like we have another division problem. This time there's no decimals, which is kind of nice for us. It's one less step to kind of take care of here. Where am I going to have enough space for this? I'll do it over here. I'll put 3, 4, 9, 9, 2. Let's go ahead and see how many times 81 fits into this. So 81 doesn't fit into 3, doesn't fit into 34. But does it fit into 349? Sure it does, right? If I round this to 80 and I round this to maybe 350, maybe just ask yourself in your head, how many times does 80 fit into 350, or how many times 8 fits into 35, right? So in our heads, this is maybe 80-ish, this is 350-ish. If you can divide those both by 10, we can think of how many times 8 fits into 35. I think if it's in 4 times, that's 8 times 4 is 32. So let's see, let's do 81 times 4 and see how close that gets us. 4 times 1 is 4, 8 times 4 is 32, so 324. Can we fit in 81 again and still be under 349? I don't think so, right? So let's put a 4 here. 4 times 81 we just found out is 324. And if we subtract here and we get a remainder less than 81, then we did a good job. 9 minus 4 is 5. 4 minus 2 is 2. So we have 25 here. It's less than 81, so we knew we got as close as we could. Let's bring down the 9 and just restart the process. How many times does 81 fit into 259? So let's see. Let's do our estimation thing again. So 81 is close to 80. This is close to 260. So how many times does 80 go into 260? That's really how many times does 8 go into 26? 8 times 3 I know is 24, which is pretty close there. So let's do 81 times 3. That's going to be 3, 2, 4, 243. So let's try this out. 3 times 81 is 243. Let's make sure our remainder is less than 81. This is going to be 6 and 1. 16 is definitely less, so that's good. And then we have this 2 that we're going to bring down and start over one more time, hopefully. 81 into 162. Hopefully this one comes to you a little bit quicker, but it's definitely not 3. It's definitely not 4. The only other thing is 2 or 1. 2 times 1 is 2. 8 times 2 is 16, so it's 162. It goes in 2 times. Maybe you saw that, and that's pretty awesome if you did. And so we have a remainder of 0. So this quotient here is going to be 432. That's the exact value of how many times 81 fits into 34,992. All right. Number 7, let's take a look at some rational numbers. Again, rational numbers are just fractions and decimals that don't go on forever and have a pattern. So looks like in this case, we just have all fractions, which are types of rational numbers. They're wondering some relationships, I think, about just how they're ordered on a number line, a horizontal number line here. So let's see if we can kind of just imagine generally where these numbers are going to be. So here's maybe a number line, and this goes forever to the left. This goes forever to the right. Maybe we could put like 0 in the middle. And these are all proper fractions except for this negative 4/3. So I think this is the only one that's going to be smaller than negative 1. So here's negative 1, here's negative 2, here's positive 1, here's positive 2. So I like positive numbers a little more. They kind of come to me a little bit easier. So look at these two numbers real quick. Maybe I'll highlight these in a different color. So these are our positive values. So they're going to be in the positive area there. If you just compare these though, which one's more to the left, which one's more to the right here. If you have 7 out of 8 and you have 7 out of 10, if you get common denominators, I think they meet at 40 for the first time. So if you do times 5 times 5, this is 35 over 40. And if you do times 4 and times 4, you're going to say this is going to be 28 over 40. So which one's going to be more to the right? Well, 35 is greater than 28. So if we're looking at this, we know that it's a proper fraction. So 7/8 would maybe go somewhere closer to here. And then the 7/10 number would go maybe over here, right? It's going to be not as quite as big there. Now, what about the negative values? Well, this is a negative proper fraction, and this is negative proper fraction. So we know they have to go somewhere between 0 and negative 1. But what about negative 4/3? Well, that's negative. I'll go ahead and maybe highlight this a different color here. This one is going to be, if you want to think about it as a mixed number, this is what, negative 1 and 1/3. So that has to be past negative 1 here. So this is this negative 4/3 here. We know that's going to be all the way to the left. The other ones to kind of think about here are going to be negative 2/3 and negative 4/5. So if you compare those fractions, I'm running out of space over there, but let's not maybe look at, we'll keep the negatives on, negative of each of these. If you want to compare these and get the same denominators, we can do times 5 times 5. This will be negative 10 over 15. And if you do times 3 to compare with the same denominator, this is going to be negative 12 over 15. So which one would be more to the left? Well, this one's technically smaller because it's a bigger negative number, and this one's technically bigger. So this negative 2/3 is technically going to be a little bit closer to 0. So I'll write negative 2/3 here. And this negative 12/15 we said was more negative, which is more to the left here. So that's going to be where negative 4/5 is. So we have them in order now. This is the smallest number. It's a little bigger, a little bigger, a little bigger, and a little bigger here. So I'm going to go ahead and write this as negative 4/3 is the smallest. I'm going to just go ahead and compare all these, right? You don't have to do this, but I think it makes it maybe look a little bit more clear. This one's a little bigger. The next fraction that's a little bigger is going to be negative 2/3. The one that's a little bigger than that is going to be 7/10. And the biggest rational number here, or the biggest fraction, is going to be the 7/8. Again, numbers that are more to the right are bigger, and numbers that are more to the left are smaller. So let's look at our answer choices. They say which one is true. So is negative 2/3 furthest to the left? Well, no, that's not true. So let's go ahead and cross that one out. It says negative 4/3 is furthest to the left. Okay, that's true. And is 7/8 furthest to the right? Well, that is also true. All right, so both of these are true here. So they're looking for a true statement. There's only one true statement, so everything else must be false here. Let's go ahead and get rid of those and try another one. For number 8, it says, what is the greatest common factor of 16 and 48? I'll do it the long way here, and then I'll do the short way. So 16, greatest common factor is the biggest number that goes into both of these evenly. So 16 has the factors 1 and 16. It also has 2 and 8, and also has 4 times 4. Those are all the factors of 16. For 48, a little trickier, but you have 1 and 48. You have 2 times 24. You have 3 times, I know 3 goes into this, 16 times, right? 4 times 12. And then we have 6 times 8. Right? So you have a bunch of common factors here. So if you just need a little refresher, common factor, of course, 1 is a common factor of all of these numbers. 2 is a common factor as well here because they're both even. Not 3, but 4 is a greater common factor. 5 is no, 6 is no, 7 no, 8. Looks like 8 is a common factor as well. And then 16 is a common factor, but I think that's the biggest number we have here. So for 16 rather. So 16 right here, while we have a bunch of common factors, we can say that the greatest common factor is going to be 16, right? That I think is a nice visual of all the common factors. Now, a shortcut kind of way I like doing is just writing these next to each other. This is called the ladder or the cake method. You think of any number that goes into both of these. Maybe a lot of people would think of 8 as like a first number here. 8 times 2 is 16 and 8 times 6 is 48. Then you just ask yourself, is there another number that goes into 2 and 6? And the answer is yes. You can put a 2 into both of those evenly. 2 times 1 is 2, 2 times 3 is 6. And then I don't think you can go any further, right? Because you have a 1 here. So all you'd have to really do is multiply these numbers on the side once you can't go any further, and 8 times 2 would be that same 16 there, right? So that might be a lot faster, but hopefully when I did it the first way, it kind of gave you a good visual of what really the GCF is. It's the greatest number that goes into both of those numbers. So 16 would be our greatest common factor. All right, let's check out number 9. Number 9, it says select each expression that is equivalent to this expression here. Again, expression doesn't have an equal sign here. It's just kind of a problem that we have. It's not set equal to anything. So it says select all that apply. There's going to be more than one right answer. What does this 3 parentheses or 3 times this n plus 6 really mean? Well, if you take this 3 times this n plus 6. We're supposed to apply the distributive property here. So this really means that there are 3 of these 1n's. So there's 3 multiplied by whatever this n is, plus, and then we have really 3 of these 6's. So if you have 3 6's, that's really saying it's 3 times 6, right? So 3 of these n's would really just mean you have 3n. And then if you have 3 of these 6's, that's really just 18. Right? So this is what would be a nice equivalent way of writing that. And so based on that, we know this one is definitely true. If you look at A, I think A is basically them saying they knew to do 3 times n, which is 3n, but maybe they forgot to do 3 times 6, and they just wrote the 6 here, right? So this one can't be true. This one is not the same thing. For C here, this one's written a little differently, but let's keep in mind that we have 4 terms here, 1, 2, 3, 4 different terms. We have these coefficients of 2n plus 1n. That's going to make 3n if you combine those. And then if you go ahead and take a look, well, maybe I can highlight those. 2n and 1n got us this 3n over here. And then if I go ahead and take this 2 and 4, those are just normal constant terms. You can add those together. 2 plus 4 is going to be 6. So you can combine them just like this as well. Notice we have this 3n plus 6, which we said was wrong earlier, so this one is still wrong. There's a fast way and a shorter way to do this next one. We have 2 of these n plus 6's, and then we have 1 more of these n plus 6's. So if you add 2n plus 6 plus another n plus 6, we really just can say that this is going to be 3 of these n plus 6's, okay? Just because we have 2 of these n plus 6's over here, and we really have 1 more of them over here. So if we have 2 of these things plus 1 more of these things, we have 3 of whatever those things are. So you can notice here that this is actually the same thing as what we started with, and so we can go ahead and put a check mark over here. I actually don't really love these arrows I'm putting here because these are equal to each other, so we can put equal signs. Let me just swap those out. I think that's a little bit more clear. This next one is another expression we can take a look at. I think this one I would probably just distribute 2 times n. This is really going to be 2n. And then 2 times 6 is going to be 12. Go ahead and add 12 plus. And then for this n over here, don't forget that this one has a little coefficient of 1 in front. So it's adding 1 more n onto it. I like writing that 1 in front because sometimes we forget it. And let's see, we have 2n plus 1 more n. That's going to be 3n. Okay, so I'm just going to 3n here. And then we also still have this 12 at the end here. So we have this 12, that's a constant. Go ahead and just write plus 12. So I guess the question is this the same thing as the other ones? Well, I think we were supposed to be getting 3n plus 18, right? So we're supposed to be getting 3n plus 18, but we got 3n plus 12. The variable term is correct, the coefficient in the variable, but these constants are not correct here. So let's go ahead and just say that's not the answer. You could do this another way as well, and you could just make up a value for n and just try it out for all of them. So stay away from using 1 or 0, but you could also just use the strategy of substitution. All right, and then you could have just tested out and said, let's let n equal 2, right? And then just try it out for each one. If you get the same answers, that works. Or we can let n equal a nice number like 3 or 4 or 5, right? Just if you're going to do this though, where you choose a random number, my caution to you is do not use 0 and do not use 1, just because anything plus 0 will always stay the same, and anything times 1 will stay the same as well. Those are the identity properties, and so you want to stay away from 0 and 1 if you're going to make up your own number to try. All right, let's try number 10. Number 10, we have, I guess, more of a geometric question. We have a bunch of these little cubes right over here, and it looks like we're being asked how many of these little cubes are going to fit inside of this big rectangular prism, or this bigger rectangular prism. So if we want to figure out how many of these little cubes fits into this rectangular prism, what we can do is figure out how many of these lengths of 1/4 fits inside of this length of 4.5. So let's do 4.5 divided by 1/4. 4.5 is the same thing as 9 halves, right? And we want to see how many times a quarter fits inside of there, so that's division. And so if we want to figure out how many cubes go across, we'll turn this into a multiplication question, and that's going to be 9 over 2 times 4 over 1. That's going to be 36 over 2, which is 18. So we can fit 18 cubes going across here, okay? What about on this other dimension? Well, if this is a little 1/4 inch cube, that means that the width is also a 1/4 of an inch and the height is also a 1/4 of an inch. So all right, so we now know that 18 cubes are going to fit across over here, but I guess the question is how many are going to fit back going this way. So let's see how many times the width of 1/4 fits inside this 5 for the width. Let's say this is going to be 5, and we want to see how many quarters fit inside. So it's 5 over 1 divided by 1/4. That's the same thing as 5 over 1 times 4 over 1. And I think that's just going to be 20 over 1, or it's going to be 20. So we know 20 cubes can fit going back this way. So we have 18 cubes this way, and then 20 cubes going this way. This one should be a little more, just because 5 is a little more than 4.5. And if you knew that 2 more quarters were going to fit into a half, that's fine too. The last one is, what if we want to fit all these quarters on top of each other in this 3 3/4? How many times can we stack those on top of each other? Well, 3 3/4 is 15 quarters. 15 quarters divided by 1/4 is the same thing as 15 over 4 times 4 over 1. You can say this is going to be 60 over 4 if you just go ahead and multiply, or you can know that the 4s will end up canceling out here. This is going to end up being 15. So 15 of these cubes are going to stack on top of each other as well here. So if we know that there's 18 cubes across here, and there's going to be 20 rows of them, 20 rows of 18, we can go ahead and just multiply and say 20 rows of 18. I'll go ahead and say 20 rows of 18. That's going to be 360, I think, across the bottom, right? But then how many layers are there? Well, there's going to be 15 layers stacked on top of each other of these 360. So if we go to multiply this by 15, we should get the total number of cubes here. So again, I'll do this on the side. This is a no calculator one, right? So 20 times 18, I'll just write this out in case it's a little bit more clear. That's 160, put a placeholder, that's a 0, that's a 2. So 20 times 18 is 360. And then we have to go ahead and take this 360 and multiply this by 15, because again, there's 15 layers of 360s. 360 is on the bottom. 5 times 0 is 5. 5 times 6 is 30. Carry the 3. 5 times 3 is 15. Plus the 3 is going to be 18. Put a placeholder here. 1 times 0 is 0. 1 times 6 is 6. 1 times 3 is 3. Let's go ahead and add these together. 0, 0. This is 14. Carry the 1 and a 5. So I think we're really looking at 5,400 little cubes are going to fill up this rectangular prism. Okay. All right, let's go on to another one. For number 11, it says the picture shows the part of a thermometer measuring the temperature in degrees Fahrenheit. The question is what is the temperature in degrees Fahrenheit shown on a thermometer to the nearest integer? So no fractions, no decimals here, right? So here's 0 degrees, here's negative 10 degrees. If you think that these are going by 1, let's see if this works. It'd be negative 1, negative 2, negative 3, negative 4, negative 5. So these aren't going by negative 1s, right? That can't possibly be true. So let's try to jump by a different number. So here's 0, here's negative 2, negative 4, negative 6, negative 8, negative 10. Oh, perfect. So that does work out here. So each little line here is going down by 2 degrees. So if this is 0, here's negative 2, this must be negative 4. So I'm just going to say that from this line of, I guess this distance here is going to be minus 4 degrees Fahrenheit. And it's because it's 2 of those little tick marks here. So it says just show the integer. And so the integer here would just be negative 4. That would be the temperature. You don't have to put any units in there. If it says just enter the integer, just put the actual number there. Okay. Here is number 12. Marshall took $36.75 to the fair. Each ticket into the fair costs X dollars. Marshall is going to be buying 3 of these tickets. Which expression represents the amount of money in dollars that Marshall had after he bought the tickets? Okay, so Marshall started off with $36.75, right? He started off with that much money, and then he's going to spend some money on the ticket. So it's going to be a subtraction after this, right? He's going to be spending money. And what is he spending? Well, he's going to buy a ticket. So he's going to buy 1 ticket, but then he's also going to buy another ticket. So he's going to take away another ticket, right, cost. And then he's going to buy a 3rd ticket here. This is one way you can kind of think about this problem. And another way to think about this, though, is if he starts off with $36.75, if he basically bought 1 ticket, then 1 ticket, then 1 ticket, you can see their coefficients are 1. You could also say really that Marshall bought 3 of these tickets, right? Because again, these are all the same thing. So instead of subtracting them individually, we can just subtract 3 of the same thing here. All right. So here's what he started with, and he's spending money. He's buying 3 of these tickets. So if you're looking for an expression that represents that, this one is going to make the most sense here. All right, let's go ahead and try number 13. It says, which one is a statistical question? Statistical questions are just questions where you can collect a bunch of data, and there's some variability in that data, so that it allows for different amounts of numbers or different types of numbers to be collected. So how tall is the oak tree? Well, that's only 1 tree, so that's not going to be a statistical question. It has to be collecting a bunch of data. This next one says, how much did the tree grow in 1 year? So this is 1 tree growing. How much did it grow in 1 year? Well, there's only one answer to that question. If you figure out how tall it is at the beginning of the year, at the end of the year, and you subtract it, that's how much it grew. That's just one answer for that 1 tree. The next one is what are the heights? Okay, we're getting somewhere. It's plural here of all the oak trees in the schoolyard. So you would take each tree, take its height, and all the oak trees have possibly different heights and different types of heights there. You can go ahead and say C makes a lot of sense here. And there's only one right answer, so we know D is not true. But if we want to just go ahead and just make sure we understand, it says what's the difference in the height between the oak tree and the pine tree? You would just take one tree's height and subtract the other tree's height. And there's only one answer to that question, so it's not statistical. All right, number 14 is another statistics question. It says the median number, this is the middle, of points by 9 players in a basketball game is going to be 12. Okay, the range, which is the biggest minus the smallest of the numbers, the points scored by the same basketball players, is going to be 7. Okay, so let's see here. A couple important things here. We have 9 players, so let's go ahead and say 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here are the 9 players. Now, when they tell us that the median number of points scored by 9 players is going to be 12, that means that the middle number is going to be 12. So I'm going to go ahead and find the middle number. So 1, 1, 2, 2, 3, 3, 4, 4. This must be the middle slot here. Let's go ahead and put 12. This is called the median. Okay. They also tell us that we know that the range, so I'm going to go ahead and do a different color here. The range, they say, is going to be 7. So the range is going to be coming from the smallest number and the biggest number when you subtract those from each other. So we know that's going to be 7. I'll go ahead and say here that the max minus the min is going to be the range, which we know is going to be 7. All right, see what else we can find out here. It says which of the statements is true. So the one of these statements are going to be true here. The other ones we maybe can't tell for certain or are just flat out wrong. So let's look at A. A says at least one player scored 12 points. Well, if they told us that the median was 12 and there are odd number of numbers, then yeah, someone had to score 12. So I think this is right away. So I think that's our answer. But maybe we want to understand what the other ones really mean here. It says the greatest number of points scored is less than 19. Well, if that's true, let's hypothetically put in a number here. Let's say this number was less than 19, the greatest number. Let's say this was 18. Do we know that has to be true? Well, if that's true, then we know the smallest number has to be 11, right? Just because they told us that the range would be 7. So if they're saying that the greatest number has to be less than 19, so then that means 18 could be true. So 11 and 18 are 7 apart from each other. Could this be true? Well, I think so, right? Because you could have this be 11, this person could be 11, this person could be 12 and 12. Again, you can have more than one same score. This could be just say like 13 and 15 and 17. So this could be like what everyone scored based on answer choice B. That is less than 19, but does it have to be less than 19? Well, could this score be 19? Sure, because 19 minus 7, this score would be 12, and all these scores here would be 12, which is okay, right? You can have the same score there. The median would still be 12, and then just say this would be like 15, 16, 18. But this is also possible, right? So you could have the range still be 7, because 19 minus 12 is 7. These could all be numbers that are 12 or smaller, right? And it can be tied. And these are just have to be bigger than 12 here. So this one doesn't have to necessarily be true, right? Because the last number, or the greatest number, does not have to be less than 19. It could be 19 here. The next one says the mean. This is the average. So if it helps to kind of like review what that means, the mean, this is the average. That's if you add up all the numbers and divide by the number of numbers, in this case 9. They're saying the average has to be more than 12. And while that could be true, I don't think it necessarily has to be true, right? So in an instance where the average would be bigger than 12, that would maybe say, like, if this was 12, 12, 12, 12, and 12 in the middle, what if these were all 19, 19, 19, and 19? This could be true, right? Because the range is still 7. The median would still be 12 in the middle. But if you averaged all these numbers together, right, all these 12s and 19s, you would get an average more than 12, right? That has to be, because it's the smallest number is 12 and the biggest number is 19. But that doesn't have to necessarily be true, because think about it for a moment here. Because, like, what if all these other numbers on this end of it were also 12? That's possible, right? They just have to be 12 or more. What if all these numbers happen to be really small, right? These numbers just have to be smaller than 12. We don't know what they actually scored. If this is true, if you averaged a bunch of 12s with a bunch of zeros, you would definitely get something less than 12. So this one's not going to make sense here. The next one is going to say if the greatest number of points scored is 16, so that kind of helps us identify what this is saying. 16 would be the greatest, then the least would be 4. So is that possible? Well, what did we say about the range earlier? I think we said the range had to be 7. So if this was the greatest, then 16 minus 7, this actually could only be 9, right? So then all the numbers in between have to be between 9 and 16 here. So it can't be a range of 4. That doesn't make any sense here, right? So we knew answer choice A was right from the beginning, but what if it wasn't the first choice and it was maybe D or C? It would be important to kind of look through all the other ones and understand why they all make sense or don't make sense. All right, let's try something in the next section now. So that's the end of the first section. This one is now going to be going on to the calculator section. Alrighty, so let's see here. Let's go into the second section. This time we're going to be able to use a calculator. So in number 15, let's see, it says which expression represents 6 more than x. I don't even know if we need a calculator for this one in particular, but it says 6 more than x. So let's see, if we have some value x, and then we have 6 more than that. Well, if you have 6 more than something that you used to have, then you would add 6 onto that, right? So that's going to be x plus 6 here. So if you take a look at our answer choices, this one right here is showing that. This first one, if you're just wanting to understand, this would be maybe the difference of some number x and 6, or you could say it as 6 less than whatever x is. So that would be that one. This one, you would say something like maybe 6 times that number x, or the product of 6 and x. So this is not the same thing. And then over here, this one is also subtraction, so it's the wrong operation here. So this would be like x less than 6 here, or 6, and then you're going to take away some unknown number. So D doesn't make sense here either. All right, that one's pretty quick. Let's move on to number 16. For this one, we are going to go ahead and use this information that we have in Part A and Part B to answer this one. So an advertising company is designing a new logo, and it's going to consist of a shaded triangle inside of a parallelogram. So we're told here that each of these little squares is going to be 1 square unit. So this is 1 square unit. This would also be another square unit here. So let's see, Part A, it says here is what is the area of this parallelogram. So the parallelogram they're talking about is A to B to C to D. So this parallelogram, what's the area? So we want to know that the formula for the area of a parallelogram is going to be area is equal to base times height. If we take a look here, what is the base? So the base would be from D to C. So let's see here, that would be 1 unit, 2 units, 3 units, and 4 units. So we know that the base of this parallelogram is going to be 4 units. And how tall is this parallelogram? Well, you go to the highest part of the parallelogram, and then you drop down to wherever the base of the parallelogram is. So this would be the height right over here, how tall this is. So this is 1, 2, 3, 4, 5, and 6. So you can see here that the height of this parallelogram is going to be 6 units. So if we go ahead and multiply base times height, this would be 4 units multiplied by 6 units, which would get us an area of the parallelogram of 24 square units. And if you need to use a calculator for multiplication, that is perfectly okay. We're going to say here that the area of this parallelogram, I think it just says in square units, so you don't have to put those units in, just go ahead and put 24. That would be our answer. All right, now what about for Part B? For Part B, it says in the new logo, what fraction of the parallelogram is shaded? Well, let's see here. We know the area of the parallelogram. Maybe we should go ahead and see if we can find out the fraction would be the area of the triangle divided by or out of the area of the parallelogram, right? So again, what fraction is shaded? Shaded is going to be area. So if we can find out the area of the triangle, I think we could do this. So we already know the area of the parallelogram is 24. What's the area of the triangle? So let's go ahead and do that on the side here. The area of the triangle would be base times height divided by 2. You could also think of the formula as 1/2 base times height, whichever formula you like more. So let's go ahead and see if we can figure out what the base and the height of the triangle is. So let's see the base of the triangle and the height of the triangle. Let's see if we can figure those out. Looking back at our picture, here is the triangle that they're talking about. It looks like it's an obtuse triangle. So let's see, the base would be from F to E here. So this is 1, 2, 3, and 4 units. So the base of the triangle is going to be 4 units. Now, how tall is this triangle? Well, this is the highest part of the triangle, and then let's go to the lowest part of the triangle, which is right over here. So the height of this triangle is going to be 1, 2, and 3. That's 3 units. Okay, so this is going to be the base and the height of the triangle. So let's use this formula. It's going to be base times height divided by 2, or 1/2 base times height. I think for this particular one, maybe I'll just use this one over here. I think a lot of people like using this one as well. So we can do half of whatever the base is, 4 units, times whatever the height is, which is 3 units. So 4 times 3 is going to be 12 square units. We have to do half of 12 square units. So that's going to end up being 6 square units. So that's going to be the area of the triangle. So the area of the triangle is going to be 6 out of the area of the parallelogram, which is 24. Then you can just go ahead and simplify this fraction by using their GCF of 6. And we know that the triangle takes up 1/4 of the area or the space as the parallelogram does here. So that being said, this C would be the answer. All right, let's go ahead and try one more practice problem for this section. Let's see, we have a dot plot here, right? Or a dot plot using x's instead. It says go ahead and use the information provided to answers part A and B for question 17. Janet surveyed a class of students. She recorded the number of hours. Notice where the number of hours are on here. That's over here. So this is going to be 0 hours, 1 hour, 2 hours, 3 hours, 4, 5, 6, 7, 8 hours of time being volunteered. And so this line plot or dot plot shows the results of the survey. So just if we're trying to understand what this is showing, there was one person who volunteered for 0 hours. There were 2 people that volunteered for 1 hour, 3 people volunteered for 2 hours, 5 people volunteered for 3, 1 for 4 hours, 1 for 5 hours, 3 people volunteered for 6 hours, 2 people volunteered for 7 hours, and 2 people volunteered for 8 hours. So just trying to make that super clear. But the first question here, it says, how many students did Janet survey? Well, that's just a number of x's. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Looks like there are 20 different people surveyed. So we can go and say that there would be 20. Again, don't feel the need to put the units on. If they're just asking for a number, just put the number in. Now, the next question says, what's the mean number of hours volunteered by the students here? And so just keep in mind, what does the word mean mean? The word mean is basically saying, what is the average, right? Average. So how do you find the average? Well, you add up all the numbers and then divide by the number of numbers. So let's see here. We know we're going to be dividing by 20 because there's 20 people, but how many hours on average did each person volunteer for? So we have to add up all the numbers here. So let's go ahead and say we have a 0 plus, I'm going to go ahead and highlight them as we go. So we have 0, and then we have a 1 and a 1. So 1 plus 1, that takes care of both of these ones here. And then we have what? 2 plus 2 plus 2. So 2 plus 2 plus 2. That takes care of all these 2's. How many 3's are there? It looks like there are 5. So 1, 2, 3, 4, and 5. That takes care of all the 3's. 1, 2, 3, 4, 5. Looks like we have 1, 4, and 1, 5. I'll do those together. 1, 4, and 1, 5. Plus, let's see, we have a 6, a 6, a 6. Let's go ahead and put a 6, a 6, a 6. Oh, it's going to bother me. This isn't going to fit here, so I'm going to move these over. Let's see, plus, looks like there's 2 7s and 2 8s. A 7, a 7, an 8, and an 8. So there's a lot of adding going on here, but to find the average or the mean, you add up all the number of hours that were volunteered by all these people, and then we're going to split it evenly amongst the 20 people to find the average amount here, right? So let's go ahead and try to condense this a little bit here. So we have 0 plus, and then over here, this is going to be just 2. 2 times 1 is going to be 2. And then let's see over here, how many 2's are there? 3 times 2 is going to be 6 plus. And obviously you have a calculator, so you could do that here. 1, 2, 3, 4, 5. 5 of these 3's makes 15. Let's see, there's 1, 4. There's 1, 5. So I just kind of did these separately for a second. Taking care of these, and you could have done this yourself also this way. 3 6's makes 18. Let's see, 2 7's is going to make 14. And then 2 8's here would make 16. All right, so we're slowly kind of like condensing this a little bit. I'm not going to use a calculator personally right now, but feel free to just do that to speed up the process. Keep in mind that when we're finding the average, we would take all these numbers and then divide by 20. And so we would do the same thing here and divide all these by 20 once you add them all up together here. Okay, let me see what nice numbers I can add together here. So 14 plus 16, that would be 30. So that's pretty nice here. I'm going to add this 2 and this 18 to also get 20 here. I'm also going to go ahead and add this 15 and 5 to make 20. And then I'm going to go ahead and add this 6 and 4 here to make 10. This 0 here, I'm just going to go ahead and drop now because it doesn't make a difference. Then let's go ahead and add all these up and divide by 20. This is actually quite nice if you really think about it. 10 plus 20 is 30. Plus 20 is going to be 50. 50 plus 30 is going to be 80. So altogether we have 80 hours volunteered total, but to find the average per person, you split those evenly amongst the 20 people. Looks like that's 4 hours per person on average. Obviously some people volunteered more and some people volunteered less, but the average is all those hours split up evenly amongst all the people there. So 4 hours on average. All right, so that wraps up unit 1 here on this practice test. Let's go ahead and check out unit 2. So let's move on. Unit 2, you get to use a calculator. Looks like we can use that for this entire section here. So let's go ahead and check out number 18. It says, let x represent any number in the set of even integers greater than 1. Okay, so even integers, so let's think about what even means and integer means. Even integers, the first even integer that's out there, integers are no fractions, no decimals, and the first even integer would just be 0, and then we have 2, and then we have 4, and then we have 6, and then 8. And these are all the even integers, just to clarify, that are 0 or higher. There are negative integers as well. All right, so these are all the even integers starting from 0. Now they're asking about even integers that are greater than 1, so we don't even want to consider the 0 right now. So the first even integer that we're talking about, I guess in this problem, is going to be 2. And so the first even integer we're talking about in this problem is going to be 2. And so their question is, which inequality is true for all values of x? So if we look at this first answer choice and we try to kind of follow the rules of saying that x is less than 0 and we have to be even integers would be like x could be -2, and then going smaller would be -4, -6, so on and so forth. And are these numbers going to be greater than +1? No, that's not true. The second one, it says x is greater than 0. So let's try to follow those rules. X has to be greater than 0, but also has to be an even integer bigger than 1. So that would be like 2, 4, 6, so on and so forth, right? And I think that is true, right? I think that's what we exactly said right over here. So this one actually makes sense. What about this third one? I know we have it, but let's just go ahead and make sure we understand these. So x is less than 4. So what could x possibly be that's an even integer? Well, it can't be equal to 4, but it could be 2, and it could be 0, that's an even integer, and -2, and so on and so forth. But these aren't all numbers that are greater than 1, right? So only the 2 is greater than 1. The rest of them are not. So that's why this doesn't work. And then if we go ahead and take a look at this last one, where we say x is greater than 4, well, x is greater than 4. What are even integers that are greater than 4? It can't be 4, but it could be 6, 8, 10, so on and so forth here, right? But that kind of leaves out the numbers of 2 and 4, which would make it okay. That have to be even integers bigger than 1. So it leaves out a couple numbers, so this one doesn't work here. All right, let's check out number 19. Number 19, Anita, I think, brings 6 dolls to her grandma's house. These dolls represent 20% of Anita's doll collection as shown in the diagram. What is the total number of dolls in Anita's doll collection? Well, this one is kind of interesting because if you just double the percentage here from 20% to 40%, then we double the amount of dolls. This would be just 12 dolls here. And if you notice here, we keep going up by 20%. So if you keep going up by 20% on the bottom here, you would keep going up by 6 more dolls over here, and you could go until you got up to 100%. So you can just keep adding 6. So this would be 18, 80% would be 24, and 100% would be this 30 here. Now a little shortcut you could do is, if you notice that 20% goes into 100% 5 times, then we could say 6 goes into 30 5 times. You could just get there really quickly there. So we could just go ahead and say that there would be 30 dolls in total for their collection. All right, let's check out number 20. For number 20, a company makes yellow golf balls and white golf balls, so 2 different colors. The table shows the company's sales of yellow golf balls for the last 3 years. Okay, so it looks like in year 1, this is how many they sold here. Number 2 looks like they sold more. And year number 3 looks like they sold even more. And just keep in mind that these are just the yellow ones. Let's see what other information we are told. The company expects that the sales of these yellow golf balls are going to continue to increase in year 4. So it has to be more than this 237,108. The company also expects that the ratio of yellow golf balls to white golf ball sales in year 4 is going to be 1 to 5. So if yellow golf balls to white golf balls, that means yellow is 1, 5 is white. So that means that'd be 5 times more white golf balls or 5 times less yellow golf balls. The third thing they tell us is the average or the mean selling price of a box of 12 yellow or 12 white is going to be $23.94. So it's the average price of them. Looks like the price isn't different for either box of 12, so that should make things a little bit easier for us. They say to estimate, so we're not going to be using exact numbers. We're just going to do some approximations of the company's total sales in dollars of the golf balls. I guess it's total golf balls in year 4. Show all your work. Also explain how you determined your estimate. We're going to go ahead and enter our estimate or write it, our work, and some sort of explanation that goes with this as well. All right, so what kind of thought process should we have here? Well, maybe this first one, this is just say about 204,000. Again, it says estimate, so let's try to make these numbers a little easier for us. This one, maybe we can just say it's around 226,000 here, right? And then maybe this one we can say this is about 237,000. So let's see what's going on between each of these years. Looks like from here to here it's going to be plus 22,000, and you can of course use calculators for this, right? And over here it looks like it is plus 11,000. So it looks like it went up by 22,000, then went up by 11,000, and we're supposed to do maybe some predictions of what's going to happen for the next year here. Now, there's multiple right answers that you can kind of go about. They're really just seeing how you think through the logic of this. In my eyes, they're kind of, I see here that it went up by 22,000, then 11,000. So that's kind of half as much this next year. And I kind of seeing like, well, maybe what if it went up by half again? So what's half of this 11,000? So I'm thinking maybe it would just go up by like 5,000 the next year. And again, I'm just using approximations here, just because, you know, it went up by like 20,000, then 10,000, then 5,000. So in my opinion, I think it's going up. It's going to go up as they told us, but I'm going to say it's going to go up by 5,000. I think 6,000 is fine too. You can argue maybe it would go up by 15,000 maybe, because that's in between these two. If you think that maybe it'll be somewhere in between there, I think any sort of good logic there would be okay, as long as you can back up your reasoning for why you chose what you chose there. So if we take this 237,000 and add on 5,000, then I'm kind of estimating here that for year 4, and again, I'm just kind of like scratch work here, or just kind of like brainstorming, that if you do 5,000 more, and again, you use a calculator, it's going to be 242,000, right? So that's maybe the estimate I'm going to say is going to be in year 4. And again, this is my estimate for the number of yellow golf balls in year 4. So we're told that the ratio of yellow golf balls, I'll go ahead and write this down here, yellow golf balls to white golf balls, we were told that ratio is supposed to be 1 to 5, right? Now, if we're saying here that we're going to have 242,000 yellow golf balls, and we're supposed to have 5 times more, then you would just go ahead and take your calculator and take this, I would take my number of 242,000 and multiply that by 5, because there should be 5 times more of these white golf balls. And so while there's 242,000 yellow ones, there would be, based on my estimate, 1,210,000 of these white golf balls here, okay? And again, this ratio of 1 to 5, they told us had to be. So if we found out that in year 4, this would be this many yellow ones, then this would be this many white ones. And so if you go ahead and take the total number of these yellow golf balls and add the total number of these white golf balls, then we should get the total amount of golf balls in total here. And again, these are all estimates here, so I'm just going to say this is approximately 1,452,000 here. This is going to be the total number of golf balls. Now, we know the price of both of them are going to be the same. They're going to be sold in boxes of 12 and boxes of 12 for both of them, so it doesn't really matter in terms of that. They're both sold for the same price, and they're both in the same size boxes. So if we go ahead and take our total number of golf balls here of 1,452,000, and we divide that to figure out how many boxes they're going to be, let's go ahead and do that. This is going to be about approximation here, but I'm getting that this is going to be 121,000, and this is going to be boxes, right? So this over here was the total number of golf balls, but they're sold in boxes of 12. So we would have here this 121,000 boxes. Now that we know how many boxes they are going to be selling, now what is the price per box? Well, again, everything is based on estimates here. So this $23.94, this is really close to $24. So you're allowed to go ahead and just approximate, because again, they're asking us to estimate everything here. So if we go ahead and take this 121,000 boxes, we multiply that by $24 a box. Again, everything's approximate here. So times 24, we're really looking at maybe $2,904,000. And so this would be a pretty good approximation of what their profit would be. So then you'd go ahead and write some sort of explanation explaining all this work that you just did, and take your time and just kind of write it out step by step. So first you could go ahead and start with saying something like, and of course it's easier to maybe type a little bit, but you'd go ahead and say that I estimated the sale of the yellow golf balls in year 4 to be 242,000, since I predicted it would increase by half as much as the previous year. You can go ahead and also go into more detail about what other things you estimated, in case we did some rounding earlier. Then the second thing maybe is, then we could say something on the lines of, using the ratio of 1 to 5, we found the total number of white golf balls, and in turn the total number of golf balls that they are going to sell in year 4. Then for a third step, and we can say next that we found out the number of boxes sold, and we did that by dividing by 12. But again, you can go ahead and keep your calculations and type those into the box as well. And you can explain here if you'd like to in more detail. If you didn't type it somewhere else with the math, you can just type it in the sentence as well if you would like to. And then for a final statement here, I think we can go ahead and say here, and conclude with saying that we use the number of boxes with the estimated price per box to find out the total amount of profits, the amount of money they would make in year 4 for all of those golf balls. So you could definitely type a little bit more than what I just wrote, but again, writing is going to take a little bit more time here, but hopefully that helps you see a full picture. If you included all these different types of things as part of your answer, you would get full points for this open-ended question, but you have to be pretty thorough here and make sure you do mention how you did some estimating. You have to mention your maybe reasoning as to why you came up with this 242,000 here. You have to also make sure we use the ratio of 1 to 5 to kind of figure out the number of total golf balls, kind of demonstrate how we kind of added these pieces up to get this total here as well. You want to talk about how we found out the number of boxes, and then we also definitely want to talk about how to figure out the total amount of money or the total sales in dollars that they actually made in that year 4. So this would be a very thorough answer, and this would earn you full points on an open-ended question like this. Okay, let's go ahead and check out one more here, number 21. Let's see what's going on. In this question, we see that Chad is driving 168 miles in 3 hours. For part A, the question says, is how many miles per hour did Chad drive? So let's see here. We can go ahead and write our rate here of 168 miles. And that is done in 3 hours. This is not an open-ended question, so we're just gonna, I guess it is, but we're only gonna, it's not a multiple choice, and it's not like an explain kind of problem. But if you want to find out the miles per hour, again, that's gonna be a unit rate, so that's per 1. So let's go ahead and divide top and bottom here by 3. If we go ahead and do that, then per 1 hour, how far did Chad drive? This is a calculator active question, so you can take 168 miles divided by 3, and this would be 56 miles per hour here. So when they say how many miles per hour did Chad drive, you can just go ahead and write that answer of 56, and that would be perfectly okay, because we know the units are going to be miles per hour, hopefully, right? But you can just type in the number and move on to the next part. It says Chad will drive 672 more miles. He continues to drive at the same rate. How many hours will it take Chad to drive the 672 miles? Okay, so let's see here. He's going to drive 672 more miles. The question is, how long will that take? Well, we know that Chad is driving 56 miles in 1 hour, and they're asking about how long. So how long is going to be X here. And we know that he's trying to go 672 miles, so let's keep the miles on top. Now, how does 56 become 672? Well, with ratios and rates, we should be multiplying. So let's take 672, let's divide that by 56, and that ends up being 12. So it turns out that if you take 56 miles and you drive 12 times further, that's going to be 672 miles. Now, if that 56 miles took 1 hour, then we need 12 times more time to figure out how long that's going to be. And so then X would just be equal to 12. So it would take Chad 12 hours to drive that 672 miles if he keeps that same rate of 56 miles per 1 hour. Okay, let's see. In part C, it says that Chad stopped to fill up his car with 11 gallons of gas. He had driven 308 miles using the previous 11 gallons of gas. All right, so it looks like that Chad was able to get 300 miles out of using 11 gallons of gas. I'm going to use GAL for the abbreviations. So when the question here says how many miles per gallon, that's the miles per 1 gallon, right? That's always what they're implying. They're always trying to find out per one of something. So let's see, when they say per of whatever unit. So that's going to be 1 gallon. And we can go and say we don't know how many miles that is going to be yet, but how does 11 become 1 gallon? Well, we could divide by 11. And so if we divide by 11 top and bottom, again, this is a calculator active one, so we can divide 308 by 11. And we're going to find out that X is going to equal 28. And again, X is representing how many miles per gallon here. And so we know that this X is going to be equaling 28, and that's 28 miles. So for each gallon of gas, they're able to get 28 miles of driving done here. All right, for this last part here, Chad continues to get the same number of miles per gallon. How many gallons of gas will Chad's car use to go 672 miles? Well, let's see here. We know that he's going to be able to travel 28 miles with 1 gallon of gas, right? That's for one of them. But how far is he trying to travel? Well, looks like he's trying to travel 672 miles, and we're going to see how much gas that's going to take. Now, let's go ahead and see. We're just basically doing a lot of different types of ratios here. 672 divided by 28 here. Looks like they are trying to travel or go 24 miles further. So if they can go 24 times miles more, right? So if they're going 24 times further, they're going to need 24 times more gas as well here. So 1 times 24, this part's the easier part, is just going to be 24. So if Chad is going to travel 672 miles, he's going to need 24 gallons of gas to go ahead and do that at that rate. All right, let's check out 22 and see what we got going on for this open-ended problem or multiple part question. It says use the information provided for part A and part B for question 22. So let's see, it says the number of blueberry muffins that a baker makes each day is 40% of the total number of muffins that she makes. Okay, so let's see, I want to kind of draw something real quick here. So I'm going to draw maybe a little double number line thing here. Let's say 0% here. Let's say 100% is all the way on the end. 40% would be not quite halfway, but a little bit to the left here. And this is going to be the amount of blueberry ones, and that's out of the total here. So let's see, he says on Monday they make 36 of these blueberry muffins. I'm going to use blue for this, but 36 is going to be over here. The question is, what's the total number of muffins that they make? Because this is only part of them. Well, let's see. Getting to 100% is a little bit trickier, but maybe we go to 20%, right? If we find out 20%, that is half of 40%. So if half of 36 divided by 2, that would end up being 18 of the total. So 18 would be 20% of the entire thing, right? Now, if you want to go ahead and figure out how does 20% become this 100%, well, that's 5 times more. And so 18, figuring out over here, 18 times 5, again, you can use a calculator for that. 18 times 5 would be 90. So you can see here that the entire amount of muffins here would be 90. So let's go ahead and put a box around that. So you can also go ahead and see that if you had 36 blueberry muffins out of 90, you could divide those two on a calculator, and that's equal to 0.4, which hopefully you know that that is 40%, right? Because you would slide the decimal over twice to the right as you convert it to a percentage. All right. All right, let's see here for part B. It says on Tuesday, the baker makes a total of 60 muffins. How many would be blueberry? Well, I'm going to go ahead and just draw another double number line here. Again, here's 0%, and then here would be 100%. But this time we don't know the number of blueberry ones. We just know the total. The total muffins is going to be 60. But think back, it's the same context here. They want to know how many would be blueberry now. Okay. It's up to you what you kind of want to do for this next part, but I think I'm going to go to 20%, just like we just did a moment ago. But some people like going to 10%, and that's fine too. If you want to go from 100% to 20%, we should divide by 5. And if we want to go from 60 muffins, which is 100%, and figure out how many would be 20%, we should do the same thing and divide by 5. And if you'd like to use a calculator and divide, that's fine. But we would find out that we'd have 20% of the muffins would be 12 muffins. Now, what if we want to get from 20% to 40%? Well, that's double the amount of percentage. So we should double the amount of muffins here. So 12 times 2 would be 24. So again, 40% of the muffins are going to be blueberry. So if there were 60 total muffins, the baker always makes 40% of them to be blueberry. We can say here that 24 of them would be blueberry out of the 60. Similar to earlier, if you go ahead and take the 24 blueberry ones out of the 60 total ones, you will find out that's 0.4, which is 40%. So these are checkable if you just look at the part to whole relationship here. All right, let's see, one final question for part 2, where we do get to continue using calculators. For 23, it says the graph shows the location of point P and point R. We can see here that point P here is located in quadrant 1. Okay, and then we can see that point R is located on the y-axis, on the positive part of the y-axis. So just make these observations as we are kind of understanding the problem. It says point R is on the y-axis and has the same y-coordinate as point P. So that just means that these two points are left and right of each other, and they have the same y-coordinate. So the distance from the x-axis, this distance here, is going to be the same as this distance over here. A couple quick things to notice here right away is that this n value, n we know has to be a positive number just because it's in quadrant 1. But I don't know if that's going to be important. Yeah, I'm just writing that down first. Another thing to maybe notice right away about this point R is, again, we know it's the same height off the x-axis. So we know that its coordinates is going to be 0, 3. We actually know that just because they said, again, they have the same y-coordinate. This is the y-coordinate of 3, and this is the y-coordinate of 3. So those are the same y-coordinates. And we knew that the x-coordinate for this r value has to be 0 because it's on the y-axis. It didn't move left or right at all. All right, now they're introducing a third point here. They're saying point Q is going to be graphed at n, -2. So this n value over here, we don't know what it is, but it's something -2. This is a y value is negative. So again, we don't know where P is in terms of its n value, but this is how far n is. So Q is also going to be going over to the right n units, but it's going to be going down -2. So let's go ahead and plot a point here that is leaving this directly under this other point of P. And again, this one is going to be, let's label it as Q. And this is going to be n, -2. And so I know this is going to be a little confusing just because we would like to know what n is. But again, these numbers should match, these variables should match, and these numbers should match just because of the same letter. So P went to the right n units and went up 3, but then Q went n units to the right, which we still don't know what it is yet, and then moved down here. All right, so what's the question that they're really asking us here? They're saying the distance from point P to Q is the same distance that it is going to be from P to R. So they're saying the distance from here, let's go ahead and mark this up here. This distance from P to Q is going to be the same as this distance from P to R here. So these distances are going to be the same. Now, if you're just trying to find out this distance right over here, the n actually doesn't even affect that at all. It's good that they match because then you can find the distance because they're up and down from each other. So you really just have to find out how far 3 and -2 are from each other. So we can go ahead and say that if we're going to find the distance between P and Q, or segment PQ, see how long that is, we go ahead and add the absolute values of their non-matching coordinates. So the absolute value of 3 is going to be 3, and the absolute value of -2 is going to be 2. So in total, we know that they are going to be 5 units apart from each other. And so when they ask the question is what's the distance from point P to point Q, we know it's going to be 5 units apart here. Okay, when they say what's the value of n, this part's a little bit trickier to maybe do here, but if we know that these two points are going to be 5 units apart, and they say the distances between these have to be the same, then what's this x value? This x value is 0, then what does this x value have to be? Again, these 2 points of P and R have the same y coordinates, so we don't really need to look at these 3's in terms of calculating that, but how far is this 0 from 5? So to find out the distance here from R to P, and so to figure out the distance between R and P, I guess you can say they're in the same quadrant, or it doesn't really matter because one's on the y-axis, but you can go ahead and add or subtract the 0. If they're in the same quadrant, you subtract their absolute values. If they're in different, you add. If it's on an axis, it doesn't matter. It's up to you. It could be 5 plus 0 or 5 minus 0, but you're going to see that's going to be 5 units. And so if that's true, or that's the case, we're able to say, well, then n does have to equal 5 here, right? If you go ahead and see that this number here would be 5, right? Then this number here would also have to be 5. And that kind of makes sense here. If this is 5 comma 3, this is 0 comma 3, they're 5 units apart. If this is 5 comma 3 and 5 comma negative 2, they're still 5 units apart here. So in terms of answering this question, it says what's the distance from P to Q? We kind of already said that. We said that's going to be 5 units. And said what's the value of n? We also found that out. So we answered both of these questions, but we didn't really explain anything yet. So how would you get full points for maybe a question like this? We can separate this in a few different statements here. So for explaining, you have time to kind of type out a very thorough response, something along the lines of saying that P and Q have the same x coordinate of n, so you can find the distance between these 2 points by just looking at their y coordinates. If they're in different quadrants, hopefully, as you've learned, you would go ahead and subtract the absolute values of these numbers, and you would find the distance between these 2 points. Again, if they're in different quadrants, you can add their absolute values of these numbers, and if they're in the same quadrant, you would subtract their absolute values, so in case you see another problem like that in the future. If it's on an axis, you don't have to worry about it because you would be adding or subtracting 0, so it's just going to be that number, so don't worry about that. And to follow up to find the value of n, what did we do? Well, we knew that the distance between these 2 points was 5, and the distance between these 2 points has to be 5 as well. So we could go ahead and explain this by saying, then you can follow up with just saying something like to find n, which had to be a positive number, since again this point is in quadrant 1. I found 5 more than 0, which is 5 to the right of 0, since point R has an x coordinate of 0. Again, point R is on that y-axis, so its x coordinate has to be 0. And so hopefully that logic kind of makes sense, and this is a pretty convincing explanation that you know what you're doing, or that we know what we're doing, and we understand the problem pretty well here. So this would also be able to earn you a full score. Again, you have a good amount of time for these problems. There's less of them in general, but you have a lot of time to be thorough with your explanation and try to use different vocab words and try to use different types of ways of being super clear about how you got from the information that you were given to the conclusion that you were trying to say, like saying PQ is 5 units long, that n is also having to equal 5, and that you can give some clear logic there. All right, so that's going to be the end of this section here for question 23. So let's move on to unit 3. All right, so let's go ahead and take a look at unit 3, which is going to be calculator active. So that's going to be helpful in some of them. It looks like we're going to have 6 different questions that we're going to take a look at here. So let's get right into it. For 24, it looks like there are 2 parts to it. There's a part A and a part B here. Let's see, we're going to use the information provided to answer both of these. So we have this diagram here. Looks like we have a horizontal number line. We're starting at 0, we're ending at 1 here. 1/2 is right in the middle. So I think we're just kind of looking at comparing maybe some fractions here and maybe working with some fractions. So James has a board that is 3/4 of a foot long. So I guess that's being measured from here to here. That's the 3/4. He wants to cut the board into pieces that are 1/8 of a foot long. So it's important to know maybe here that if this is a quarter or 1/4, then this should be half of that. So half of 1/4 would be 1/8. So I'm just going to go ahead and write that in as 1/8. Now, if this is 0, this is 1/8. This actually is 2/8. This would be 3/8. I'm going to go ahead and write that in. This is then going to be 4/8, which is the same thing as a half. This is going to be 5/8. Go ahead and put in 5/8 over here. This is 6/8, which is simplifying to 3/4, which means this next one here is going to be 7/8, which also leads us to 1 whole being 8/8, but 8/8 is just 1 whole here. So I'm just going to write those in first. The question is how many pieces can James cut from this board? Explain how James can use the number line diagram to determine the number of pieces he can cut from the board. Okay, so he wants to cut the board into 1/8 size pieces, and he wants to see how many of these he can kind of cut from this 3/4 foot long board here. So how many, the question really here is how many times does 1/8 fit inside of 3/4? And that problem is going to be 3/4 divided by 1/8. Anytime you're trying to figure out how many times something will fit into something else evenly, or how many times it goes into it, that's a division problem. So if you go ahead and take a look at this number line, notice how many times an 1/8 fits in here. Goes in 1 time, then 2 times, 3 times, 4 times, 5 times, and 6 times here. So we should be able to cut 6 of these here, right? So if you could take a look at this problem as well and kind of just rewrite this, if you look at it this way as well, we need to use the number line, but if we also just think about the division algorithm here, you just take the first fraction and multiply by the reciprocal of the second fraction. So this is just 24/4, which you can see simplifies into 6 as well. But the question does say to how you can use the number line, so let's go ahead and do that. We can go ahead and say, that James can see or notice that 1/8 is going to fit into the 3/4 6 times on the number line. So James can cut a total of 6 of these 1/8 foot size pieces if he has that 3/4 foot long board. Something along the lines of this would be a good explanation. Now, I kind of already did this earlier, but for part B, it says write an equation using division that represents how James can find the number of pieces. And so this is really just wanting to kind of see the connection here. So I already did it earlier, but when you, again, the whole idea is to prove that you understand how the number line connects with the equation and how the understanding that if something is fitting into something else, it's division. So you can really write an equation that looks like this and say that the 3/4 is the whole thing, and then the 1/8, that's how big the pieces are we're trying to fit into it, and that this would be equal to, let's just say we can call this x, and then we can go ahead and define here and say that let's let x represent the number of pieces. So this right here would be in our equation here, just because we have an equal sign. And so if you go ahead and solve this, x would be the number of pieces. And it doesn't matter really how you write it on the left or the right side, but we can say x would be equal to 3/4. And then you would go ahead and type all this out. You would write 3/4 multiplied by 8/1. And if you can cross cancel, great. If you can't, that's okay too. You can just multiply the numerators and multiply the denominators. And then you can just talk about how you have to simplify a little bit here, and you would say that x is equal to 6. So this is one way you could write it, and another way you could just kind of really try to see if you can get full points here is putting the equation together. You can just say 3/4 divided by 1/8 is equal to 6. This would probably be the best final thing to go ahead and write here, and just say that 6 is the number of pieces, 3/4 is the total length of the board, and 1/8 is the size of each of those boards. So just going ahead and labeling that real quick for you. That right there is the entire length. The 1/8 is the length of one piece, and the 6 represents the number of 1/8 foot size pieces that can fit into the 3/4 foot piece of wood. All right, so there's that one. Let's take a look at 25. This one looks like we also have 2 parts here, so let's take a look at part A. So for part A, it says which equation can be used to determine the price in dollars of one notebook here. So let's see here. 4 notebooks cost $6.40. Let's go ahead and define maybe our variable. Looks like they're using P. I think P, they say, is going to be representing what? It says P in dollars. That's the cost of one notebook here. So if you take the cost of one notebook, which is P, and we are buying 4 of them, so P plus P plus P plus P, that's 4 of these notebooks, and this is the price of each one of them. That should equal $6.40, right? If you are going to be buying 4 notebooks here. Now keep in mind that this is the price of one notebook plus the price of one notebook plus the price of one notebook plus the price of one notebook. There's always an invisible coefficient of 1 in front, just because 1 times anything stays the same. But if you go ahead and combine all these together, right, you can add all the ones together and say that 4 of these prices of notebooks is going to be $6.40. right? So we can go ahead and say, if we, based on this, that if we look at answer choice C here, this is saying 4 of these prices of notebooks would be $6.40. So that kind of makes sense here, that if you have 4 of the same thing, it equals $6.40. A doesn't really make sense because this is the price of one notebook. If you take the price of one notebook and then split it by 4, it doesn't make sense for it to then cost $6.40, right? Again, you're getting 4 notebooks for $6.40, so the price of one has to be less than $6.40. So this one doesn't make sense. This is the price of one notebook again, and why would we take the price of one notebook and divide it by $6.40 to get 4 here? I'm not really sure why we would take that price of one notebook and divide it by the price of 4 notebooks and get 4. That doesn't really make any sense to me either. And then D here, this is saying $6.40, which is the price of 4 notebooks. If you take that and multiply it by the price of one notebook, I really don't see why that would equal 4 either. So it doesn't really make sense why you would multiply the price of 4 notebooks by the price of one notebook and then always get 4. That's a little bit strange there. So the next one says to actually find out what is the price of one notebook here. So if 4 of these prices of these notebooks is going to be $6.40, then you could go ahead and solve this by dividing this side by 4 and dividing this side by 4. I'm using a fraction bar for division. Now, if you do that, 4 divided by 4 is just going to equal 1. So this is going to be the price of one notebook. And then on the right side, again, this is calculator active, so you can just go ahead and divide 6.40 divided by 4. And so if you do that, if you do 6.4 divided by 4, we should get $1.60. So the price of one notebook would be $1.60 here. So I think you can just go ahead and write 1.6 or 1.60. I think either way is going to be fine, but you don't have to put any units when you're typing your answers in. If you wanted to check this, you could just take this 160, plug it in right over here. If you have 4 of these 160s, you do indeed get $6.40. Okay, let's go ahead and try 26 here. All right, in 26 for part A, it says a group of hikers buys 8 bags of mixed nuts. Each bag is going to have 3.5 cups of these mixed nuts. These are going to be shared evenly amongst 12 hikers. How many cups of these mixed nuts will each of the hikers receive? Show your work or explain your answer. Enter your answer and your work or explanation in the space provided. There's not a ton of space here. Typically, you get a whole box to kind of be going ahead and typing in here. But you should maybe write something along the lines of the total amount of mixed nuts. The total amount you can write or type would be equal to 3.5 cups. That's going to be for one bag, but you have to multiply that by 8, right? And then you can just go ahead and show this step by step, but you're going to need to turn these into improper fractions. So 3.5 is the same thing as 7 halves. 8 is going to be 8 wholes. And then if we go ahead and multiply the numerators together and the denominators together, we're going to get 56 over 2. And you could cross cancel if you know how. I'm just not going to right now. If we simplify this, this would be 28 total cups of these mixed nuts. So that's the first thing you're going to want to go ahead and do. I realized I spelled amount wrong. I'm going to move that over and put a T in there, or N in there rather. Oops. Total amount is that right there. And then what would be the next thing we have to do? Well, they're sharing this amongst 12 of these hikers. So maybe we can write the amount per hiker. You could just go ahead and label that and write that as the first thing, so you can explain and show what you're finding here. So if we're going to find the amount per one hiker, you would take the 28 cups and split that evenly amongst 12 people. Now notice it's not going to be a whole number here, it's going to be a fraction. So if we go ahead and do this, this is really just going to be 28 divided by 12 is really just 28 over 12, right? So that's kind of the important thing to kind of notice, that when you're doing division, you can just rewrite it as a fraction. So you don't have to really stress out too much about that. And if you want to see how many times 12 fits into 28, well, it fits in 2 times. 2 times 12 is 24, which is 4 away from 28. So as a mixed number, you would know that it's 2 4/12 of cups per person. But then you go ahead and just simplify this a little bit more and divide top and bottom by 4. So you're going to say it's going to be 2 1/3 cups here. So you just want to go ahead and maybe do these two steps for part A. You first want to go ahead and find out the total amount and write this expression. Then just go ahead and solve it to get this answer of the total amount of nuts. And the next thing is you would want to go ahead and find out the amount per hiker. I just realized I also did the same thing here. I don't know what's going on right now. Good thing I'm doing math and not English. So the amount per hiker here is the total amount of these mixed nuts split 12 ways. Keep in mind, division is really just written as a fraction if you'd like to. It makes it a little bit easier. Or you could gone and just did long division if you wanted to, I guess. But you would get the same answer of 2 1/3 cups per hiker. All right, so that would be just showing the work. It does say show the work or explain. I think this is pretty clear, but if you wanted to elaborate because you had the extra time, writing a couple sentences to back it up is not a bad idea. All right, let's check out part B. It says the hikers plan to visit a scenic lookout. They will rest after they hike 2 miles. Then they will hike the remaining 1 3/4 miles to the lookout. The trail that the hikers will use to return from the lookout is half a mile shorter than the trail that they will use to go to the lookout. Each hiker will bring a 1/4 or 1/4 gallon of water for each mile to and from the lookout. It says determine the total distance in miles each hiker will hike, show your work or explain your answer. Determine the total number of gallons of water each hiker will bring, show your work or explain your answer. Enter your answers or work or explanations in the space provided. So again, you would have a bigger box to kind of make this a little bit more thorough. I'm going to try to do my best here with the space we have. So let's go ahead and find the total distance that each hiker will hike first. And so let's start by saying, let's go to the lookout. The distance to the lookout, they said it's going to be 2 miles first. Then they said that they were going to go ahead and rest. And then it's going to be 1 3/4 the rest of the way to get to the lookout. So if you go ahead and add these two together, we're going to know that this is going to be 3 3/4. This is going to be total miles, I guess, to the lookout from the beginning to the end. But then they tell us that when we are going back from the lookout, this is going to be a little bit of a shorter route here. They said it's half a mile shorter. So if you go ahead and take that 3 3/4, which is how long it took to get up there, and you have to take away a half here, you would go ahead and just write those out. And you can use improper fractions if you prefer. This would be 3 3/4 minus, and using equivalent denominators or common denominators, 2/4 and 1/2 are the same thing there. So I'll just go ahead and highlight that these are the same thing, and also just go ahead and highlight that these are the same thing here. Now that we have common denominators, we know that when you go back down from the lookout, this is going to be 3 1/4 miles. Now if you go ahead and take this information and find the total distance, you would just go ahead and add this 3 3/4, that's on the way up, plus the 3 1/4 on the way back. You would find out that that is going to be 7 total miles from the bottom to the top, and then the top to the bottom if you're going from whatever you start to the lookout and then the lookout back. Total of 7 miles. So this 7 total miles here is going to be the total distance that each hiker is going to be hiking. The next thing we have to go ahead and do is determine the total number of gallons of water that each hiker is going to bring. Now keep in mind that each of these hikers is going to bring 1/4 gallon of water for each mile that they're going to be hiking, right? So the expression that you would go ahead and write here is going to be that the gallons per hiker is going to be 1/4 gallon of water per each mile. There are 7 total miles that each of them are hiking. This is going to be 1/4 times 7 over 1 if you write them as proper and improper fractions. That's going to be 1 times 7 is 7, 1 times 4 is 4. We have 7/4 gallons of water, which as a mixed number is going to be 1 3/4 gallons. And this is for each individual hiker. So this would be our answer for that second part there. And again, I'm running out of space a little bit there, but hopefully you could spend a little bit of time just typing a sentence or two of why we are multiplying there and what our answer kind of means there. But for each of those miles, it's 1/4 gallon and a total of 1 3/4 gallons per hiker. For 27, it says there's 5,280 feet in 1 mile. It says how many inches are there in 2 miles? Oh boy. So we got to do some unit conversion here, it looks like, right? So let's see here. We know that there are going to be 5,280 feet, and that's going to be in 1 mile. So it's asking about what if we want to go to 2 miles. So let's go ahead and figure out first, what if we go to 2 miles? Well, if we want to go to 2 miles, then we would double the amount of miles. So we should double the amount of feet here. So good thing this is a calculator question, but we can take this 5,280 and double it. And so we would, if we double it, we would find out that this is going to be 10,560 feet in 2 miles. Now the question they asked though is how many inches, right? So we want to figure out if we're going from feet to inches. We know that there's going to be, well, you can go ahead and look at our, there should be like a unit conversion chart they can click on during the test here, and know that 1 foot is the same thing as 12 inches. Those are equivalent to each other, right? Inches are smaller, feet are bigger here. So we have 10,560 feet, right? But we want to turn that into inches. Now, if each one of these feet is 12 inches, you can go ahead and just multiply this by 12, and you'll figure out how many inches that there are going to be. So again, this is a calculator question, so don't do any long multiplication here, but just go ahead and multiply. Again, 1 foot is 12 inches, but we have 10,560 of them, so that would be 126,720 inches. Okay, now hopefully that makes sense because these are in feet and these are in inches. The number for the inches is way bigger. It's 12 times bigger, but they're also 12 times smaller. So that hopefully does make sense here. So answer choice C is going to be our answer. If, again, this was the number of feet, this can't be our answer choice because this is in the wrong units then. So hopefully you can see right away that doesn't make sense. But in terms of looking at B and D, there's no real mathematical way to get to D using the correct thinking and the correct logic with the correct numbers. All right, so let's check out 28. All right, let's check out a couple open-ended problems to kind of finish off Unit 3. It looks like 28 and 29 are both going to be open-ended. In 28, Sam's 2 new aquariums each hold exactly 200 gallons of water. One aquarium will hold small fish, the other one's going to hold large fish. Now he needs new fish for his aquarium. So he'll buy 5 small fish for every 10 gallons of water in the aquarium. He's also going to be buying 8 large fish for every 40 gallons of water in the aquarium. This kind of makes sense. The larger fish just need more water to kind of swim around in. It says, what's the total number of fish that Sam will have? What will be the ratio of Sam's small fish to large fish? Show or explain the steps you use to solve this problem. Enter your answers and your work and explanation in space provided. I'll do the best I can with the space we have here, but I'll try to kind of reason through it a bit too, and you can practice typing it out as well. Let's start by answering the total number of fish that Sam will have here. The first thing I'm going to go ahead and is write a ratio that we know, or a rate that we know for the small fish. There are going to be 5 of these small fish for every 10 gallons. So I'm going to go ahead and just write a little rate or ratio here as the beginning part. We know that we're going to be having 200 gallons of water for this tank here. So if we're going to have 200 gallons, I guess the question is how many small fish are we going to be able to have? You get a calculator, so if you need to, you can do 200 divided by 10. You'll find out that's 20, or 10 times 20 is 200. So if you do that on the bottom, we should do it on the top here. We're going to find out that we're going to need 100 of these small fish, and that's 100 small fish that's going to go into that 200 gallon tank. If you go ahead and set up another rate or ratio here, that we know that there are going to be 8 of these large fish, and that's going to be for every 40 gallons of water, right? So we know the tank for this one, they tell us, is also going to be 200 gallons. So I guess the question is how many times does 40 go into 200? And you can divide or figure out that's going to be 5 times more. So we're going to need 5 times, we're going to have 5 times more of these large fish. So that's going to be 40 of these large fish that are going to go inside this 200 gallon tank. So again, you could maybe just explain with a sentence or two that we're just using equivalent ratios here to kind of scale this up, scale up like a fish, to get to 200 gallons for both. But if you take a look here, we see that we have 100 small fish and we have 40 of these large fish. So for the total fish, you're going to want to go ahead and say that that's just going to be 100 plus the 40, which is going to be 140 in total here, right? So that hopefully clears up how to do that first part, which is just figure out the total number of fish that Sam's going to have. And for the second part, it just asks what's the ratio going to be, and it's specific in saying that it's small fish to large fish, so you have to make sure you put the small fish number first. So if we go ahead and do that, I'm going to write it over here because I have a little bit more space, but small fish is going to be 100 and large fish is going to be 40. Now if you go ahead and take this ratio here and simplify it down, you can divide these both by, I guess, 10 first. I'll do it in steps of what I think maybe most people would kind of see first. So this would be a ratio of 10 to 4. Notice how you could have simplified a little bit more here, so you can divide these both by 2. If you wanted to just divide both by 20 first, that's fine. But this is basically a 5 to 2 ratio here. So that would be the answer to that second part of that question in terms of what's the ratio here. And you would just say that there are 5 small fish for every 2 large fish. And hopefully that makes sense. There's more than double the amount of small fish than large fish from what we said earlier, from 100 of the small ones to the 40 of the large ones. So you can say something along the lines of, we know the ratio is going to be 100 to 40. If you go ahead and simplify it down, you will get a 5 to 2 ratio here. There's 5 small for every 2 large fish. All right, let's check out 29. In 29, Brianna's teacher asks her which of these 3 expressions are equivalent to each other. Looks like we have 3 expressions. So expression A, we have 9x minus 3x minus 4. Expression B, we have 12x minus 4. Expression C, we have 5x plus 1x minus 4 here. So Brianna says that all 3 expressions are equivalent because the value of each one is negative 4 when x is equal to 0. Brianna's thinking is incorrect. It says identify the error in Brianna's thinking, determine which of the 3 expressions are equivalent to each other, explain or show your process in determining which expressions actually are equivalent. And so we have 3 different things that we have to do here. And so first, let's see like what's going on here when they say that Brianna thinks that each one's negative 4 when x is 0. So is that true? Well, it must be true, but let's see here. If we do 9 times 0 minus 3 times 0 minus 4, well, this thing cancels out because that's 0. That also becomes 0. So yeah, this first one does equal negative 4 if x is 0. And this next one, this would be 12 times 0 minus 4. Now 12 times 0 is just 0, so 0 minus 4 is negative 4 here. And for this third one, this would be 5 times 0 plus 0 minus 4. Well, this ends up just being 0 plus 0, which is 0, and 0 minus 4 is negative 4. So you can see here that, yeah, these are all negative 4 if x was 0. But I guess, does this happen if x is 1? What about if x is 2 or 3 or 4 or 5 or 6 or 7 or any other number? Or does this only happen to be a coincidence when x is 0 here? So in terms of identifying the error in Brianna's thinking here, again, anything times 0 is going to be 0, so it's kind of a tricky number to use for checking. And so the main thing we kind of want to say for identifying the error in Brianna's thinking is that Brianna really only just checked one time here when x was 0 in this specific scenario and found out this negative 4 was the value of the expressions. As long as you say something along the lines of Brianna really has to check more than one value. Again, it's important to kind of know that if you're going to choose hypothetical numbers, staying away from 0 and staying away from 1 are a good rule of thumb, just because of the identity properties, right? The reason you'd want to kind of wrap your head around and be able to explain is that anything times 0 is just going to be 0, or anything plus 0 is also going to end up being just the same number, or anything multiplied by 1 is also going to stay the same. So these aren't really good numbers to use because they're kind of tricky sometimes in not telling the entire story of what's going on. For the second thing that they're asking us to do here, it says determine which of the 3 expressions are equivalent. And so something you could do here, I'll do it below, is maybe let's just say let's let x equal 2, right? That's a safe number to be using here. So if you want to look at expression A, if you look at expression A here, it would be 9 times 2 minus 3 times 2 minus 4, which would be 18 minus 6 minus 4. That would end up being 8 here. Okay. If you look at expression B, B is 12x, which is 12 times 2 minus 4. So 12 times 2 is going to be 24. 24 minus 4 is going to be equal to 20. So notice how they're not the same thing. And if you look at expression C, C is going to be 5x, or 5 times 2. Plus here another 2, and then take away 4. So 5 times 2 is 10. 10 plus 2 is 12. 12 minus 4 is going to be 8. So notice here that A and C have the same value here. And it says which of the three expressions are equivalent. I think we can go ahead and say that expressions A and expression C are equivalent to each other, right? We just saw that this did work when x was equal to 2. If you want to try x is equal to 3 for good measure and x equals 4, x equals 5, I think you'll see that A and C are always going to be the same and B is not going to be the same. Again, B happened to be coincidentally equivalent if x was 0, not a great number to use. And there's a kind of a shortcut way you kind of do this if you really understand expressions quite well. You could just simplify this expression. The 9x minus 3x can combine to make 6x. You could write 6x minus 4. And then based on that, you could make the argument that these are not the same thing. While they do have the same constant terms of -4, they don't have the same coefficients here. 6 and 12 are different, so that's not going to work here. So again, you can just look at the simplified versions of these expressions. Over here, if you do the 5x plus the x, 5x plus 1x is 6x. So you can see this is 6x minus 4. So again, you can kind of just see that these two expressions just are the same because they have the same coefficient and the same variable and the same constant term. But you can see this middle one, expression B, while it does have the correct constant term, it doesn't have the correct coefficient. So you can go that route as well if you don't want to do substituting in different values of x. It's a little bit more efficient that way. Now, in terms of this third part, it says explain or show your process in determining which of the expressions are equivalent. I kind of just went over both ways there. I think what probably the most common thing most people will do is substitute other values of x in. Again, earlier I substituted in x is equal to 2, and I was able to prove that A and C were equivalent. But again, just choose anything that's not 0 or 1. That's one route you could have taken. And the other strategy you could have used is to combine the like terms by adding the coefficients together or the constants together and just kind of talking about how the expressions simplify down and how some of the constants or coefficients are either the correct numbers or the incorrect numbers. But this one is definitely going to save you time, but you have to know your vocabulary a little bit better. Okay, so hopefully you found this video helpful. This goes over an entire 6th grade NJSLA practice test. Hopefully you found it helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. If you'd like to download a free copy of the blank PDF, you can find a link to that below, as well as the answer key annotated PDF. You also find a link to all those things in a Google Doc that kind of has a bunch of different resources from 6th grade math all the way up to some AP calculus classes as well. So hopefully you found the video helpful, and I'll see you in the next one.